student, welcome back to the video number 3. In this video, we will be talking about hypothesis testing with 1 sample and 2 sample. Please do not forget to watch video number 2 on confidence interval calculation because this is a prerequisite for this video. The lesson outline is what is type 1 and type 2 errors, hypothesis test for a single population mean when the population standard deviation is known, hypothesis test for a single population mean, this time the population standard deviation is unknown, and third one is hypothesis test for a single population proportion. Okay, so let's do the first things first. What exactly is a hypothesis? So when we're talking about the statistics, a hypothesis is a proposed explanation for an observed phenomena. It is like making an educated guess about what might be happening based on the available evidence. So one job of a statistician is to make statistical inferences about the population, right? Based on the sample taken from the population. Because as you know, the population, it's so huge that in practice, we don't have access to all the individuals, maybe because of time, budget, or many other reasons. Confidence interval that was discussed in video number 2 is a one way of estimating a population parameter based on the data that we gather from the sample and the analysis we do on the sample, right? Another way would be to make a decision about the parameter. Now, let me tell you what I mean by making a decision. For example, a pharmaceutical company advertises that it's their new medication. It's 75% successful against, let's say, a particular type of cancer on average. Now, what we have to do is to do a study as a researcher to see if their claim, which is made by the pharmaceutical company, is correct or not. So making a decision about the claims that a pharmaceutical company or any other company is making is called hypothesis testing. What is a hypothesis testing? It actually involves collecting data from a sample, right? And evaluating the data. In other words, analyzing the data. Then the statistician make a decision as to whether or not there is sufficient evidence based on the data that we gathered from the sample to accept or reject the claim. As you can see here, there are 2 methods for making inferences about populations. Remember, we always study on samples, and our purpose, our goal, is to make inferences about population. Method 1, that we already discussed it in video 2, is based on confidence intervals, and method 2 is making a decision about the parameter, which this decision making, it's called the hypothesis testing. Now, in the next slide, I will be discussing about the elements of a hypothesis testing. Where should we start? How to come up with the hypothesis? What is the goal? What is a null hypothesis? Alternative? What is the test statistics? What is the rejection area? So here, our goal is to make a statement regarding the unknown population parameter based on the sample data. Now, let's talk about the null hypothesis. It's actually a statement. Remember, guys, it's a statement it's not a question. It's a statement regarding the value or values of unknown parameters. As a side note, parameter relates to the population. Typically, it will imply there is no association between explanatory and response variables in our application. And the null hypothesis, when we are writing it, it always contains an equality. As opposed to alternative hypotheses, these two are exactly the opposite of one another. The alternative hypothesis, again, is a statement contradictory to the null hypothesis and will always contain an equality. Well, in other words, within hypothesis testing, as I mentioned, the null hypothesis, which is denoted by H0, and the alternative hypothesis is denoted as H1 or HA. The null hypothesis often represent the status quo or a belief that there is no difference. There is no effect or no difference, while the alternative is the opposite and it says that it should be otherwise. So how do we actually test this hypothesis? Because we have to either accept the null or reject it or accept the alternative. So here, let me walk you through the process. We have to test the statistic. How? We collect data relevant to the variable or phenomena we are investigating. Then we choose an appropriate statistical test on factors like the type of data and the research question in mind. Then next is the p-value, which I will be discussing later. The p-value is a measure that helps us determine the strength of the evidence against the null hypothesis. Just to let you know, a small p-value indicates strong evidence against the null hypothesis, while a large p-value suggests weak evidence. Okay. Now the next step and the final step is making a decision, right? So let's move on and talk about each of these factors in more detail. The null hypothesis, shown by H0 or HO sometimes, and it is a statement of no difference between the variables. While the alternative hypothesis, shown with H1, it claims about the population that is contradictory to null hypothesis and what we conclude when we reject the null hypothesis. This is usually what the researcher is trying to prove. Okay, now let's see what happens in reality. Because like every research comes with some innate errors, which could be due to measurements, recording of data, or any other sources of. Now in here, I want to talk about what happens, what are the outcomes when we do, a study, when we collect data and we come up with a null hypothesis. So I created this table or chart. Here it's reality, true or false, and then this is the measured or perceived, which is based on your sample data. There could be some sources of error, right? So we want to know what is type 1 and type 2 errors. So let's take a look at this table. When in reality, the H0 is correct and the data we collected from the sample is actually showing that this H0 is correct, then everything is matched together. There is no error, right? But let's assume in reality H0 is false, right? But when we collect the data and we come to the conclusion that the H0 is true, well, here there is a mismatch between the reality and what we come to the conclusion as per the sample data. So here there is some error. This type of error is called type 1 error. So the probability of type 1 error, it's usually shown with alpha. And it shows the probability of rejecting the null hypothesis when the null hypothesis is true. Then there is another scenario which in reality the H0 is true, right? But based on the sample data and the analysis we did, H0 is false and should be rejected. Here again, we have another type of error, which is called error type 2, and this one, it's actually is when the decision is not to reject the H0, when in fact H0 is false. This incorrect decision is called type 2 error, and the probability of this type of error is shown with beta, as you can see here, and it's the probability of not rejecting the null hypothesis when the null hypothesis is false. The fourth scenario would be in reality and based on the sample that we gathered and calculated, the null hypothesis should be rejected or is false. Well, there is a match between reality and measured, so this one is correct. Now, what should we know is that the alpha and beta should be as small as possible because they are the probability of errors. If these two are large values, that means our study is not a very good one. And we have to sometimes, in some circumstances, if the error is high, we have to reassess. While on the other hand, in reality, it's never zero. For the rest of the video, we will be talking about the p-value. First, let's see what is the p-value by definition, and then how we use it to reject or do not reject the null hypothesis. Let me start defining p-value by giving you a very simple example. Imagine you're a scientist conducting an experiment like testing a new drug. You give the drug to a group of patients and compare the results to another group who didn't get the drug, which is called the control group. Now you want to know, is the difference in the outcome between these two groups real or just due to chance? Now, here it's where the p-value comes in. It tells you the probability of seeing the observed result, or something more extreme, if there is actually no difference between the groups. Or in simpler terms, it helps you determine if your findings are statistically significant. Here is how it works. If the p-value is low, which is typically less than 0.005, it suggests that the observed difference, it's unlikely to be just to random chance. So you might conclude that there is a real effect, like the drug is actually working. But if the p-value is high, it means that the difference could easily be due to the chance alone, and you don't have a strong evidence to support your hypothesis. So in a nutshell, the p-value helps scientists decide whether the results are meaningful or if they might be just seeing some random fluctuation. We actually use the sample data to calculate the actual probability of getting the test result, which is called the p-value that we just discussed. Now we want to see what is the relationship between the p-value and accepting or rejecting the null hypothesis. So they usually call the p-value and the null hypothesis buddies. Reason why? Let me explain it to you. Let's say again, you are a researcher trying to test a new idea, like whether certain medication reduces blood pressure or not. Now, before you jump to conclusion, you need to consider a null hypothesis, right? The null hypothesis basically says there is no real difference or effect even if you take the medication or not with the control group, right? It's like saying the medication doesn't actually work, or there is no evident change in blood pressure in just, by taking the medication. And any change in the blood pressure between the control group and the other group who has already taken the medication is just due to random chance. So when you run your experiment and crunch the numbers, you get a p-value. This little number tells you the probability of seeing your results if the null hypothesis were true. Now, take a look at this table which summarizes all of these. So if your p-value is really small, right, which is typically less than 0.05 with 95% confidence interval, it means your results are unlikely to occur if the null hypothesis were true. In other words, you've got a strong evidence against the null hypothesis, right? You might then reject and conclude that there is a real effect, like the medication is actually lowering blood pressure. So if I want to summarize it again, if your p-value is low, it suggests that your results are unlikely under the null hypothesis, right? Then, conversely, when your p-value is greater than your alpha, you do not reject the null hypothesis, right? Or in other words, you fail to reject the null hypothesis due to insufficient evidence. There is a very important point which I put up here. When you do not reject null hypothesis, it doesn't mean that you should believe that null hypothesis is true. It only means that you do not have enough evidence to reject the null hypothesis. So in essence, p-value actually helps you weigh the evidence against the null hypothesis. They are like the detective in your research, guiding you toward meaningful conclusion. Remember, the p-value and the null hypothesis go hand in hand, and understanding this relationship is key to extract meaning or making sense of your research finding. Now, let's do an example. The same example that we did before. It's the efficacy test for the new drug. A company has new drug, wishing to compare it with current standard treatment. Federal regulation tell company that they might show and demonstrate that the new drug is better than the current treatment so that they can get the approval. Okay, so the pharmaceutical company is running some research, right, where some patient received the new drug and other they received the standard old treatment. Numerical response of the therapeutic effect is obtained. Now, the parameter of interest here is the mean of the population. So, in this example, the researchers usually start with the assumption that the new treatment has no effect, which is represented by the null hypothesis. Then the null hypothesis would state that the new drug doesn't offer any significant advantage over the existing standard treatment. To test the hypothesis, the company would run some RCT, which is randomized controlled trial, where participants are randomly assigned to either receive a new drug or standard treatment through the trial. Various parameters such as efficacy, safety, or other effects would be measured and compared between the two groups. After collecting and analyzing the data, the company would assess whether there is enough evidence to reject the null hypothesis. If the results show that the new drug performs significantly better than the standard treatment with a low p-value, which is typically less than 5%, then the null hypothesis would be rejected, which will indicate that the new drug is indeed more effective than the standard treatment. Okay, now the orders of operation or the orders of steps when we want to come with a research, right? So the first thing is coming up with the null hypothesis. Null hypothesis is always assuming that there is no effect whether we use the intervention or not. Based on the null hypothesis, we come up with an alternative hypothesis. Then we should be careful about the type and type 1 and type 2 errors. Then we collect our data, right? And then find the p-value and then make a decision. I hope this video was able to help you understand the hypothesis testing, null hypothesis, alternative hypothesis, and then its relation to p-value. I will see you in the next video with more practice questions. Thank you.